Hi, welcome back to the Engine Performance Expo. Again, I'm Lake Speed Jr. with Total Seal Piston Rings, and today I'm here with my good buddy Judd Massengil at, where are we, Judd?
I think it's Samtech.
Samtech. That's the School of Automotive Machinists and something technology. Okay, here we go. So we're in Houston, Texas, right? All right, so what's this little hot rod here behind us, and how does that relate to what you guys do here?
Well, Lake, obviously what we do, starting with the engines and we finish with the cars, okay?
Right.
But we start there, we start in our theory class, we go through the, other words, machining, boring, honing, balancing, all that kind of stuff, the CNC, et cetera, et cetera. And then this is like the finished product.
Okay.
Okay. Now, this obviously was built by Chevrolet. It's a 2013 Copo Camaro. Okay. And we do the engine for it. I mean, every piece of it. You know, we quote blueprint as you do for stock eliminator. Those rules are a little gray sometimes, you know.
That's the fun part, by the way.
That's the fun.
Gray area.
There you go. There you go.
All right, wait. So, Judd, you're saying your students build the engine for this race car that you guys then race in NHRA?
Right.
Okay, well, that's kind of cool because obviously the racing, that's the sizzle. That's the important, cool stuff. So, one thing I want to do is talk about how racing a car translates back into what you guys teach here and why that's important for someone that's maybe new to the industry or looking to advance their skill set, because through those windows back there I see some hot CNCs, and so how can you relate this race car to that CNC machine?
Like we have a saying here, if you can put chips on the ground, that's what the industry calls it.
Yep.
In other words, you can machine and put chips on the ground, you're going to work the rest of your life. Okay, now what you're going to be doing, it may not even be automotive.
Right.
It could be anything. But once you get, I do the theory, okay? We go up there, we get the theory of, all the different systems, rings, bearings, gaskets, all that. Engine, put it on the engine dyno, okay? And we'll change cams, heads. I mean, sometimes we're kind of like a race team. We'll stay here all weekend, 3 o'clock in the morning, sometimes 24 hours a day. We just come in shifts and we're getting ready to go to a race, just like a real, race team would.
Well, you got a race car. I think you are a race team.
There you go. There you go. So what we do is they see the real side of this, okay? And we hope when they come out of here, they're capable of going and getting a job in the industry. Some of the people like to stay in the shop and work. The other ones like to go on the road and work on the cars, from Top Fuel to NHRA Stalkers or whatever. Circle track, drag race, it makes us no difference, And the whole thing's about, if you're mechanically inclined and you apply yourself, we think we have a curriculum that'll get you a job.
Okay, back to your chips on the ground. So I think that's a great saying, that if you can put chips on the ground, then you can make a living doing this. Now, the old school way of making chips on the ground was a Bridgeport or a lathe, or the guy, porting and polishing and doing it that way. Back to the CNC machine. That's what I really want to talk about, is what you guys offer here as a way to bring somebody into that modern age. If you're not versed in CAD, CAM, Mastercam, using one of these machines, I really want you to kind of take the viewers and move us through how you take what you learn in this race car. Really, what the race car is really the proof in the pudding of what you're doing from your theory upstairs in the classroom to learning how to put chips in the ground using those machines versus the old school way of doing it.
Yeah, it's taken over the industry, there's no doubt. I will say this, there's always going to be a place for a mill and a lathe in the shop, because you don't want to have to, a small project. Today, the CNC stuff, the big difference that we think in our program is that you're going to learn to program, not just set up the machine and hit a button, and letting it go through its phases, okay? We're going to teach you to program this thing, okay?
Okay.
You're going to have that down, and then what you're going to do is you're going to go down to the machines, okay? And you're going to literally start CNC, small pieces, wrenches, whatever, to start with. And then the most complex by far is the 5-axis CNC in the cylinder heads.
Right.
Okay? And the head department will do their work on the flow bench. They'll take what we call a pro port or a raw casting, And we may wipe out 2 or 3 heads using up ports, but we just keep trying to get numbers. It's not all about numbers, but I can assure you that generally when it has larger numbers, it goes faster. But there's wrong ways and right ways to get the numbers.
Okay.
Okay? That we do that, and then one of the big differences, we have what's called a digitizer in layman's terms.
Ooh,
okay?
That's a cool tool. We're going to get that later.
You know,
Yeah.
Yes, that right there, we can take the work they've done in the head department, on the flow bench, porting room, etc. Okay, and we can just literally scan that entire port and make a program. In other words, the students will be able to do this. They will make the program that will then be put in the CNC to take another casting like that and do the intake runners, the exhaust, okay, combustion chambers, and whatever else we're doing at the same time.
Awesome. All right, well, Judd, hook me up with somebody to show us how that actually happens in real life. Because this sounds cool. Let's get to it. All right, so Judd hooked me up with John. So you're in charge of all of this madness in here,
Yes,
right?
sir, I am.
All the cool science projects.
All the fun stuff.
All right, well, cool. So Judd already told us a little bit about that ferro arm and how you use it to digitize parts.
Correct.
And the biggest thing he was talking about is, the old school way of making chips, you put it in the lathe, you put it in a mill, whatever, you find and you fit and you make, and that's a machinist skill. And not that there isn't machinist skill in doing this, because we're going to talk about that, and that same thought process is still required. But you go about doing it a little bit different. So talk to us a little bit about, explain to the audience how you program and tell that machine to make those chips.
Okay, so what we start out with is we get a cylinder head from our cylinder head department.
Okay.
They've obviously gone through, they've hand ported this. Now,
Right.
the old school way was doing all the cylinders exactly the same. It takes a long time.
Yeah, there was no exactly the same, by the
Exactly.
way.
You get them close.
Right,
Close.
yeah.
Okay, so what this allows, this machine right here, so that's our ferro arm right here. This is called the coordinate measurement machine.
CMM.
CMM.
Right. Okay.
So what we're able to do is we actually be able to take the port robe, go through the entire port, and we make a digital copy of it.
Okay.
So that digital copy right here gives us this little kind of a hazy mesh right here. But if we zoom
All those little dots are coordinates, right?
exactly. So if we zoom in on this, every single dot is an XYZ location.
Got it.
So from that, I'm able to take this data, reverse engineer this into a surface that I can work with.
Okay.
Okay.
So essentially you're taking this tool
Correct.
and creating a 3D map
Yes.
of that port.
Yes.
That map is then converted into a solid model. Am I following that right? I think so, right? Okay, all right. So go carry on.
Okay. So from that, we do a little bit more work to it. And so I get this. Okay. So this is actually a solid object that I can work with and I can apply a toolpath to.
Okay.
So now the orange things here we see here and some lines coming out of it, this helps with the toolpath control.
Okay.
So that way when it goes into the Haas over here, we actually have control over how that tool's going to cut throughout the length of the port.
All right.
Okay. So once I have that, I use Mastercam to come in here and create my toolpath. Now it's a little bit hard to see right here, so let's turn this off. So here is part of my toolpath.
Okay. So each one of those blue lines is the path the tool will follow
Correct.
in order to create that part.
Exactly.
Okay. So what? For those who don't know, explain what is Mastercam.
So Mastercam is a CAD/CAM software. It allows us to do design work and also allows us to apply toolpaths so we actually create a finished product.
Okay. All right.
So
So it's like the translator.
yes.
So you got this idea in your head. I want this shape,
Right.
but the machine's not psychic. It can't figure that out.
It only knows what you tell it to do.
So the Mastercam is what tells it, okay, to make this shape, you need to take this tool, follow this path as it goes through this big chunk of fillet or
Exactly.
whatever it is
Exactly.
to actually make the part. Okay.
Right.
I'm learning something along the way too.
And what's really nice about this software here, so we have a digital copy of our original intake port here.
Okay.
Now, with that, obviously I need 4 more.
Correct.
So what I can do with the software here is tell it to repeat
Ooh.
several more times. So you can see here, obviously this port right here was digitized in the center of the head.
Right.
But I want to start here with my cutting, so I just move my toolpaths around and make copies of it. So it takes that exact port and duplicates it throughout the entire length of the cylinder head.
So that's really cool if you have a symmetrical head. What about if you have those?
Don't get me started on that. Don't get me started on those.
Oh, we just created all the hate in the whole world right there, right? I couldn't help myself, right? Symmetric head, that makes life easy. If it's a non-symmetrical head,
Small block Chevy.
I didn't say that.
So the small block Chevys, we have to actually have a lot more done. They have to have both intake ports on one side done,
Right.
one exhaust done,
Right.
and then it takes a little bit more work to get it
More practice with Mastercam.
Exactly.
Hey, run along, get some feel of that. Okay. All right, carry on. Sorry for the digression there.
And also, not only that, but we can also do this exact same thing with the exhaust ports too.
Okay, yeah.
So obviously we have that. Now on this particular head, we do not need the combustion chamber, so that was not digitized.
Okay.
Because we're not doing anything with the combustion chamber. If we were, then we would again use the ferro arm, digitize that, and exact same process, make digital copies of it.
Right now, so essentially, because of the way you fixture it in there, could you put all of those operations into one program where you do the exhaust, intake, and combustion chamber?
Absolutely.
Right, but you model them all three separately, you can do them all separately, and you can do them individually.
Right, so over here you can see all my tool paths for doing this entire length of the head.
Okay?
Okay. Now the way we have this set up on the Haas there, I can actually pull. Maybe I want to do just the intakes only on one head.
Mm-hmm.
Maybe I like the exhaust ports from another head for whatever application I'm doing.
Right.
I actually pull from different programs and run that throughout the head.
Okay, so once you've digitized that port design, do you have the ability to play around, like if you want to make a change, and say, okay, we had this port, we flowed,
Right.
we like that, we ran okay, but we're really thinking we might want to change this to it. It's a lot of work to go add material
Right.
to a head that's already ported. What ability do you have to modify?
So like you're talking about, like let's say right after the push rod area where this is opened up, maybe we want to reduce that a little bit.
Right.
Now in Mastercam, it's possible, but it's extremely time consuming.
Okay, so you don't want to use Mastercam to do that.
Right.
So what are you going to use to do it?
So if I were to do that, I'd probably move over to SolidWorks.
Okay, SolidWorks.
More of a just design focused software that gives me a lot more capabilities than just Mastercam. Mastercam does a lot of great things, but it's still limited in certain ways.
All right, so SolidWorks is where you want to design something from scratch, essentially.
Well, not necessarily from scratch, more complex components.
Okay.
It's a little bit easier to work with.
Okay, all right. So in that case, you say take that model, export it to SolidWorks, essentially, make your modifications to it, then bring it back into Mastercam to create the tool paths to make the chips.
Correct.
Okay. All right, I'm having fun. I hope you're having fun watching this. I'm having fun. Okay, so what are the things that, obviously this is computer-based and everything, and some people get nervous about computer skills.
Right.
What you've shown me so far seems pretty intuitive for somebody that's been around normal machines.
Right. It's not too bad. I have students all the time. Usually I'll have one or two students who are limited skills with the computer because, they just use it for email and social media and things like that. But it's not that big a deal because we go through the entire process of how to work everything.
Okay.
So it's not no big deal to go, hey, how do I save to my thumb drive? Oh, this is what you do.
Got it.
In the world.
Fantastic. Okay. Any other kind of thoughts on before we start trying to make some chips and move on?
Before we make chips,
Okay.
we got to verify what we're doing.
Ooh.
Okay, we have to
Verify.
make sure.
Okay.
We
Now
have to make
trust
sure.
but verify.
Exactly.
All right. Let's go.
Okay, so what we have here now is I have a rough simulation of the cylinder head
Okay.
and the fixture plate that goes onto it. Because especially when you start dealing with 5-axis work, the machine, the tool in the port, the machine has to tilt just one way and it crashes.
Ooh, crashing's bad.
Costs a lot of money.
Especially race cars, but these tools and these machines make some race cars look cheap, actually.
So what I can do is I can use this solid model right here to simulate the tool cutting. So what happens here should happen in the machine if I've done my job right.
It's a simulation, essentially.
Exactly. So we can watch this, go through and cut now. So we're going through, the tool's tilting, making its motion. We're looking for when the tool comes out, is it gouging along that port?
Okay.
Or when it picks up and repositions to another port, is it gouging or crashing going through the head again?
Got it.
Because as programmers and operators here, we're telling the machine exactly what to do. So if we tell it to do something wrong, the machine doesn't know any better, it's going to do that.
Okay. So, dumb question. How does it know the length of the tool and the positioning of that, where that fixturing is in space?
That's part of the program.
Okay, part of the program is that, okay.
So let's look at this here. So everything looks good. We've verified. I like it. Nothing's crashing. So part of our toolpath process when I create the toolpath itself So this is a custom tool that we have that works with our configuration.
Got it.
So I know all the parameters of that tool. And you
Okay.
can see here, we have a full simulation of that tool. Okay?
So you've got a model of the tool.
Right.
Obviously, whoever made the tool has a model for it, so they can take that information, put it in. Now you can. I'm having all kinds of fun right now. How about you guys? This is super cool. All right, carry on. I'm having fun. Let's show what we got.
Then this right here, this configuration, this setup, matches exactly how everything's going to be inside the machine.
So it's not just the tool path itself; it's also the fixturing,
Right.
because it's not like you're just going to go put it in there. There has to be a fixture to hold it, just like any machine operation.
Exactly.
So
we
the
have to
fixturing
make
is
sure we
a
have to have
model.
zero location
Okay.
that everything's going to be based off of, because if my zero location's different from what I programmed for it, nothing's going to work. It's going to be a bad day.
Not like bad days. No crashing.
No crash.
No crashing, no bad days. I've crashed enough tools and broken enough tools in my life on a regular lathe. I can't imagine what I would do with one of these
right.
without help. So, okay, so what's next in the process here?
So after this, after we verify everything's good, then I'm actually get the G code. This G code is what runs the machine. That's our programming language.
Okay.
Okay. So I'll tell Mastercam I'll just do one tool path here, keep it quick and simple.
Sure.
So Mastercam, hey, give me the G code for this tool path. Go through, tell where to save, ask you some questions.
I'm biting my tongue right now to not make a G-code joke. Just know that. I really want to, but I'm not, because I'm bad at jokes anyway.
It's okay. We do it all the time.
Okay, good. All right, fair enough.
Got to live that G code life.
Here we go.
So for instance, we have program name, Sam Racing for us, posted
Yep.
for the machine,
Yep.
because no machines are going to be the same. All the fixturing in that machine right there, we designed in-house.
Okay,
So they're not going to be able to actually take this program and run it somewhere else.
got it.
Okay? Because if they did, again, bad time.
Yep.
Okay? So this is our programming language, and so we're telling it what tool number to use.
Okay.
We're telling it what origin location inside the machine to use, and then how to position that head to get started.
Okay, and where to move it to.
Exactly.
This is my basis point. Move, start from here.
Right.
Then we can begin to work from there.
Right. Then from there, we're telling it how fast to turn the spindle,
Okay.
how fast to start cutting.
All right.
Then after that, it's just
That's your speeds essentially right there.
exactly.
All right.
Exactly. And then after that, we're just running through tons and tons of lines of code for all the motions.
That's awesome. So earlier, before we started filming, you were showing me some parts and pieces because, hey, this is really cool, really neat stuff,
Right.
especially when you're talking about kind of designing in space. And back to SolidWorks, where you can make that part in SolidWorks. And okay, but how do you know where that part fits, and how do you match these things up? Because it's one thing to make a part. It's something different for that part to actually fit. Trust us, if anybody's ever designed a part or made a part, what happens? You make your cuts, either a piece of wood or a piece of metal or cylinder head or whatever, you go to bolt it up and guess what happens? Yeah, right?
Doesn't work.
No, it doesn't work. So talk about that a little bit. How can we utilize this technology to make that process go more smoothly? So I'm thinking, from my NASCAR days, you made some stuff out of really high-end exotic materials. They weren't cheap.
No.
And so when you go destroy a billet piece of unobtainium, it usually is expensive.
Very expensive. Okay, so another benefit of having this ferrule arm right here is not just doing cylinder heads.
Okay?
So we have this project right here that I have on the screen here. Now this is a Holley single plane manifold designed originally to run a carburetor.
Right.
Okay. Well, we don't want to run a carburetor. We want to put a throttle body on this. So we have to come up with an adapter that allows us to do that.
Okay.
Okay. So we use the ferrule arm to digitize, make a digital copy of the carb flange,
Right.
and then also a digital copy of the Holley bottom side of the mounting surface of the throttle body. That way we can mirror the two together.
Yep.
Okay. So we come up with these little adapters right here.
Okay, so for people who don't know, explain to them what you're seeing, because
Okay.
that doesn't look like metal.
No, obviously it's not metal. Okay. So
Okay.
this is plastic. So we use a 3D printer to conceptualize our design. We want to prototype that out because I don't want to take a large chunk of material, spend the time programming, machining it, and you can go, well, that wasn't quite right or not quite what we're looking for.
Okay.
When I can use a very cheap amount of filament from a 3D printer to prototype the design. And the first one on the left was the original one I designed.
Okay.
Came up with that. Our EFI guy goes, you know what? I want to see one a little bit shorter. It looks
Okay.
like maybe something that could fit in an actual car. So modified the design, came up with one on the right-hand side.
Okay.
So here you can see we have the card flange
Yep.
going into the Holley throttle body flange.
Got it.
Okay.
And you digitized both of those with a ferro arm, and then you just made your piece to fill in the difference, and then you can obviously adjust the taper and things like that for performance differential, maybe.
Right.
Okay.
And so once we have this finalized design, again, just because I have design doesn't mean it's going to work. We want to mock it up and make sure everything looks like it bolts together.
Perfect.
Then look at everything, open up the throttle blade, go, yes, that's a transition I like. Let's keep going with it. So from there, so here we're back in Mastercam, so I have the part right here. So that's what I want to program.
Okay.
So I'll come through, start laying out my setup. So like the red block right here represents a large chunk of material I had. A little bit of overkill, but it was a big piece of material I had on hand. I can get the job done.
Yep.
Okay. So then we also see conceptualization of our work holding. This is the fixture. These are the aluminum jaws being cut to hold it into that operation.
Got it.
Okay. So we go through. These are our tool paths. Again, this is actually our first setup right here. I cut it from the card flange side. Then here it is in that first operation.
You got to finish both sides of the part, so you got to go rotate it.
Right. Multiple setups.
Yep.
Less is always better, but not always going to happen. So here it is, the first side roughed out.
Okay.
Finish out the inside to from one side. Go through.
Mm-hmm.
Picture the jaws being cut next. So now we cut the jaws to match up with the card flange side.
Yep.
So that way in our second operation, we can now clamp onto it.
Yep.
Tool path signaling all the extra material that's got to be removed.
Spindle time. Spindle time.
Here it is, getting done.
The coolant guy and the chip selling guy love this, by the way. The tool guy loves this. Oh, yeah. Cut some more off there. Yeah.
And so here's our finished part.
Nice. So this was just your personal project you did for your car, right?
Oh, yeah, no problem.
No, I see this is part of the curriculum, right? This is something you guys do on a daily basis that's part of the curriculum here at Samtech.
Absolutely.
All right, so the student that comes here is going to be doing these things. Not necessarily, obviously we do talk conceptual, Justin talked about you start off with the theory, but this is something that students here get to do hands-on, making these parts.
Absolutely. These design I did myself, but the digitization with the ferro arm, that was the students.
Okay.
Yeah. This whole putting the cylinder head and everything like that, that's the students.
And again, all these parts and pieces end up going on that race car. Not every single one of them, right?
Exactly.
But some of those parts and pieces do end up on the race car, going down the racetrack, and then you get to actually, that proof is in the pudding.
Mm-hmm.
You don't just do this in theory and make some parts that looks cool, and but that's nice, but you actually get to put it on a car and see how it performs, so you get to kind of take it full circle.
Exactly. And even if a student has their own race car too, if they want to design parts for that, do it.
Okay.
I encourage you.
That's awesome. Well, that's good. That's good stuff. Any other parting thoughts, or for people who are getting into this that don't really know a lot about CNC work, that may feel like, hey, this is something I know about, but I am intimidated by it? I mean, what would your advice be to somebody that's new to using this kind of equipment, this kind of software to make those chips?
Get educated. You have to have education on this equipment. Whether you get education from us, from YouTube, from various other sources, do it. Do it. It's worth it.
I mean, just what you showed me today doesn't seem that intimidating to even someone like myself, who I'm a machinist dummy, right? I know some stuff, but I'm a tribologist, I'm not a machinist, so that's really cool. Well, thank you so much for your time. We really appreciate it. Thank you for watching this segment of the Engine Performance Expo.
Back in studio here at the Engine Performance Expo, and we are coming down the stretch, just minutes away from Warren Johnson, and then the big finish where we're going to get John Callies and Scooter Brothers and John Kazi and Warren and Lake and myself all at a table, and you can guess who's going to contribute the least.
Me.
And me. But Chuck Lynch is back with us. A little opportunity for some Q&A, guys. So if you have some questions, put them in the chat section right now as we come down the stretch. And, this has been so great, Chuck, to just see the information exchange. And for you guys at AERA, that's really what your prime focus is, information exchange. If someone has a question or an old combination, you can dig up what the original specs are supposed to be.
Absolutely. We have a 100-year-old library. We're coming up on our 100-year anniversary, and tons of information. We shared some old information with Lake about a vehicle he
tomorrow. I brought it with me. We'll show it tomorrow during the AERA segment, for certain. So yeah, you guys are a wealth of knowledge and information. And I know one of the things that you guys have a kind of a connection with Samtech, that you guys actually, the Samtech program actually teaches some of your certification classes?
Right. We have an online certification program. In years past, many people may have been familiar with like ASE, Engine Machinist Certification Program, and that has gone away, and we have a online certification, and we do some of a deeper dive into, machine tool principles and things, and it's not necessarily just automotive machining.
Right.
So it gets you into the basics of machining,
right?
And then we hit, okay, where do we use that in the automotive world, in engine machinist world?
Well, kind of like what Judson was saying in the video, that if you can put chips on the ground, you can earn a living,
right?
Whether or not you're working on cars or race cars or what, if you can put chips on the ground, you will be able to make a living
wherever you go.
Yeah, exactly. So I think that was kind of the interesting thing about that segment, is we're so used to these machines and what they're capable of doing. And I think back to what Doug Yates was saying before, and we can quiz Warren again later on, being able to go through different iterations of cylinder heads during the same week, dynoing every day. Well, that's not possible without that machine. But if you don't know how to operate that machine, it's impossible. Without an operator, you can't do anything. So how do you get to be an operator?
Right. So, and actually my son chose to go down that path, and he does the CNC machine work. And, it's funny, the kids think, I'll never use algebra in life and so forth. And okay, it's nothing but formulas and so forth. So there's an opportunity for the kids in high school still. I can use this to make my living. And then, schools like Sam and so forth, if you're a gearhead and you love that,
right?
And then, okay, and I can bring this component of it. I mean, I know people that do R&D during the day and make widgets at night, and that generates cash flow, and they're doing the research and development during the day. And so that's the cool thing. And then these machines now, they give us the ability to reproduce, the whole repeatability and reproducibility.
Right.
It's like I hand you the mic and you measure a part and you get the same reading 3 times. That's the repeatability component. But if you hand it to me and I can measure it and that's the reproducibility component. When we're talking about making ports, okay, when we were doing it with a grinder, we may have got close. These are next level.
Right. Yeah, you weren't close with ports by hand. No, this is close.
Right. Yeah, that is amazing. And hey, before we move too far along, just a shout out to Hidden Horsepower. We had Judson Massengil on one of our great episodes.
Oh, exactly.
And you have to check it out, like how he met his wife.
Yes, great story.
And how the school came to be. I'm not going to tell you right now, but it is a much cooler story than you can possibly imagine.
Well, one thing about Samtech that's kind of cool is because they do have the race car. Whether if you're a kid not interested in algebra, but you're interested in going fast, well, maybe your motivation to learn algebra is going fast.
Absolutely.
That race car kind of gives it context. It's like, why would I want to know this? Well, because that's what's going to get you down the track faster.
And think about it, and everything is related to math. Where do triangles not matter in what we do? Like these vectoring, looking through X, Y, Z. If I can do those things and I can repeat those things, I can go fast every single time. Not part of the time, of course, Murphy exists and we may break some things, but if I follow these things, these standards, then hey, we can go fast all the time.
Well, I think part of these things too is kind of neat is that for people that maybe don't feel like they have experience doing hand tools, well, this is the way that you don't have to have that hands-on experience to be able to begin to learn. Now, I think like you said, it's important to learn how things are machined so that you can understand what you're trying to do here. But
I know from a computer perspective, if you're more interested in screens, well, these are screens. This is math, and there's a way to get in there. So it's the pathway in, right? We want more people in the industry because, in my opinion, internal combustion engine ain't going away anytime soon. It's going to be around for a while,
especially for specialty things like we use them for,
right?
You know, racing and pulling and going fast, etc. I feel that way. Chuck, this has been great. Super excited about what we've got going on tomorrow as well, and we're just going to keep it going. You look like you're having a good time here at the Expo.
Absolutely. A lot of friends, industry friends, or my true friends.
Oh, exactly, yeah.
Exactly. And so we're going to keep it going. We've got our next guest. Thank you very much. Chuck is going to step out, but we've got a great guest. And when we get our guest in position, I want to tell you about the people who make it possible. This didn't happen by accident, folks. In fact, we've got media partners like the folks at Engine Labs, and you can check them out at enginelabs.com. Race Engine Technology, which is a great periodical, and folks at NHRA.tv, who are simulcasting the Engine Performance Expo, and also a great place to watch NHRA drag racing. You should check them out, and I really appreciate them being involved. And sponsors like Rottler Manufacturing and Total Seal Piston Rings, CWT, which Randy says is kids with toys. I don't know if that's true or not, but I like it. Straub Technologies, Pro Charger, Blueprint Engines, Edelbrock, Morel Lifters, of course, Mr. John Callies, Holly, Goodson, Valvoline, Ultrasonic, Dart, Elgin, AERA. We just spoke with Chuck. Comp Cams, ARP, Driven Race Oil. That's this guy had something to do with it not long ago. Molly, of course, Motor State, Summit Racing Equipment, all on board as sponsors of the Engine Performance Expo, and we really appreciate you guys. If you're out there and you stepped up to help make this happen, not only are you helping us do this, but you're also helping the next generation of engine builders and machinists and anybody who wants to try to get something done. And for the people out there, use these companies. Also, the contributors like EFI University, Ben Strader, of course, and Robert Yates Racing Engines, Shaver Specialties Racing Engines, which, Lake is over there, like he's got the key to the back door, of course, LN Engineering, Petty Enterprises, and Samtech.edu, all contributing part of the show and helping out the Engine Performance Expo. And one more thing, Scott Performance Wire's got an October promotion going on. Get this, October, still many days left in October 2021. 50% of all eligible purchases, will go to the Pretty in Pink Foundation, which supports uninsured and underinsured breast cancer patients. So for more information, you can go to sparkplugwires.com. That one's probably pretty easy to remember. Sparkplugwires.com for Scott Performance Wire. Their October promotion, 50% of all eligible purchases will go to the Pretty in Pink Foundation. I can't think of a better charity. And thank you, sponsors. Thank you for helping support the EnginePerformanceExpo.com. And now, another live... What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.